As the number of satellites in Earth's orbit continues to swell, the European Space Agency, ESA, is taking significant strides to protect these valuable assets and ensure the long-term viability of our space environment. With over 11,000 active satellites currently in orbit, and projections indicating that tens of thousands more will join them in the near future, the challenge of preventing collisions in space has become a pressing operational concern. Additionally, there are more than 1.2 million pieces of debris larger than 1 centimeter floating around, which complicates the situation even further. To tackle the complexities of space traffic management, ESA has launched an innovative initiative known as the Collision Risk Estimation and Automated Mitigation (CREAM) project. This initiative is a crucial part of ESA's broader space safety program aimed at enhancing the safety and sustainability of space operations. Traditionally, satellite operators had to manually evaluate potential collision threats, devise avoidance maneuvers, and communicate with other operators, a process that is often slow and fragmented. This manual approach can lead to inconsistent communication among stakeholders, making it difficult to make timely decisions. The CREAM system is designed to revolutionize this process. By automating many of the tasks involved in assessing collision risks, planning maneuvers, and coordinating with other operators, CREAM provides a more efficient, technology-driven solution to managing space traffic. The primary objectives of this system are to minimize false alerts, accelerate decision-making, and significantly reduce the workload for operators, all while enhancing the overall safety of space missions. One of the standout features of CREAM is its capability to connect a diverse array of stakeholders, including satellite operators, space situational awareness service providers, regulators, and observers. This interconnected network facilitates quicker and more transparent decision-making, particularly in scenarios where two active satellites are on a collision course, as opposed to dealing with inert space debris. In some instances, the system may even be able to negotiate maneuver agreements between operators with minimal human intervention. If any disputes arise, CREAM has the ability to escalate these issues to a mediation service, ensuring that all parties are treated fairly while safeguarding space assets. Since its inception in 2020, the CREAM project has reached a significant milestone under the guidance of GMV, with contributions from Guard Time. The core components of the system are being integrated into a cohesive platform. Currently, the prototype operates from the ground and is capable of generating collision alerts, suggesting actionable avoidance maneuvers, and facilitating coordination between operators. The next phase involves expanding the pilot program to incorporate additional decision support technologies. Simultaneously, ESA is preparing for in-orbit demonstrations, which will include piggyback missions where CREAM will be deployed as a digital payload, as well as a dedicated mission to fully test its capabilities in real space conditions. Beyond immediate collision avoidance, CREAM has the potential to influence the development of future regulations governing space traffic management. The establishment of clear rules of the road in orbit has long been stymied by a classic dilemma. Enforcing rules is challenging without the technology to implement them, and the adoption of technology is slow without established regulations. By integrating CREAM into spacecraft, operators can easily adhere to emerging best practices and international standards. In turn, regulators will have a robust monitoring tool to ensure compliance. The system's flexibility allows non-technical users to update standards within CREAM as regulations evolve, ensuring its long-term relevance in a rapidly changing orbital landscape. As the landscape of low Earth orbit becomes increasingly crowded with mega constellations, commercial launches, and private operators, effective space traffic management is more critical than ever. ESA's CREAM project marks a significant advancement toward creating a coordinated, automated, and equitable system for preventing collisions, reducing the creation of space debris, and maintaining the orbital environment for future generations. If successful, CREAM could serve as the foundation for an international framework dedicated to space safety, demonstrating that with the right tools, technology, and collaboration, humanity can continue to explore and utilize space without transforming it into an unmanageable junkyard. But here's where it gets controversial. As we push forward with these advancements, how do we balance innovation with the need for regulation? Are we prepared to enforce the necessary rules to keep our space environment safe? We invite you to share your thoughts in the comments below. Do you agree with the direction of the CREAM project, or do you see potential pitfalls that we should be wary of?